So good afternoon, everyone. If you're here for the talk on the Yahoo Ad Manager Plus, you're at the right place. Just change the name on the presentation a little bit to make it a little more description what we're talking about. I'm David Wilcox. My esteemed colleague Bobby Evans is here to answer all the hard questions you might have, but I get to talk. So yes, we're going to talk about storm topology that does conversions and joins. And let's see, a professor way back in the dark ages when I was in college, my professor would tell me, "Okay, I'll tell you what I'm going to tell you, and then I'll tell you what I told you." So using that model, what I'm going to tell you. So first we'll do a kind of a quick introduction for what the Yahoo Ad Manager Plus does, and you know why we're doing this in the first place. A brief overview of the topology as it exists, not including what I'm talking about. Talk about conversions and why we want to do them, and then a first unsuccessful implementation. And that seemed like a good idea at the time. It didn't work very well. And then the second, much more successful attempt, and where things are right now. So yeah, the Ad Manager Plus, it's, you know, Yahoo's in the business of selling ads, obviously. This is an ad platform that does a real-time auction for ads. So a user comes to a page. You go to a publisher, the publisher sends a message off to the ad server saying, "Hey, I'm about to serve a page about cars or sports or what have you to this particular user. What kind of ad should I show?" And the ad server runs an auction, and all the advertisers say, "Hey, I'll pay you a penny. I'll pay you 10 cents. I don't know, whatever they're going to pay to show an ad to that particular user, and whoever wins the auction gets to show the ad." So that's all part of the ad serving stuff. That's a whole nother group. I don't know how that all works. It's very complicated. What we do is part of the back-end processing. So obviously we've shown ads to users. Users might have clicked on things. There are various other interactions with the user. And the advertiser wants to know, okay, how many ad impressions have I gotten? How many clicks did I actually get? Who's been seeing those ads? Where have they been running? So we collect all that information and make it available to the reporting system that can talk to the user. And the kind of thing that the advertiser can get is how many clicks, how many impressions, their revenue and cost amounts in the currency for the particular advertiser, and then all of those aggregated over a plethora of dimensions. Where the user was, what kind of device was the user using? Is it an iPhone or an Android or an old PC? So anyway, so that's what this system is all about. Going in a little more detail about the environment. So, right, so the user goes off to a web page. I kind of said a little bit of this before. It goes off to a web page. The web page has a little JavaScript in it that goes off to the ad server and says, "Give me an ad." When the ad is shown to the user, there's a beacon fired that goes off to one of our beacon servers. If the user clicks on something, there's another indication. If we show the user a video and he watches enough of the video, there's another indication. Those all go off to the beacon servers, and the beacon servers send the to our topology. Now, Data Highway is Yahoo's system for collecting all these events that happen on servers all over the world and pulling them all together into the central locations for processing in the back end. So we do our processing, a little more about that in a minute, and then the results are sent out to a Druid cluster. Druid is really good at taking in whole bunches of data and then doing aggregations on them. So the reporting system queries out of Druid. The advertiser can go to the reporting system and say, tell me how my campaign is running, and the reporting system will pull the appropriate information out of Druid and present it in pretty graphs and bar charts and things like that. An underlying principle in this whole thing is fast and close enough. It's storm topology. The thing is that the advertiser may have a campaign that starts, say, at 1 o'clock in the afternoon. And boy, at 1:01, the advertiser wants to know, so how's my campaign going? Am I getting impressions? Are people seeing my ads? Who's seeing my ad? So they want to know, like, right away. Partly because, maybe they're only running that campaign for a day or so, and if they need to tweak some parameters and, change how they're targeting their ads and that kind of thing. So if we lose the occasional event, that's okay, because it's a Lambda architecture. Not shown on this slide, kind of in parallel, there's a batch processing run that takes the same events. They get them from data highway at the same time that streaming them to our topology. They're dumping them off to HDFS, and then there are a bunch of batch jobs to do similar processing. Actually, they do a lot more processing than what we do in the storm topology, and those are the numbers that actually you can send an invoice on those. But ours aren't accurate enough for that. So types of events, pretty quick. So we get impressions that are shown an ad. We get a click because somebody clicked on something, kind of obvious. Engagements are various and sundry other interactions with an ad, like watching a video or some such, and beacons that we'll talk about in a minute. So in internals of the topology, I haven't gotten to conversions yet. Internals of the topology, it's fairly simple. We get the events in, the data highway does an HTTP push to our spout, and we get the events, and they're formatted as protobuf, so we have to go and pull the little bit of information out of the events that we're interested in. There's a whole lot of stuff in there that we don't care about. So we pull out what we do need, and then there's some other things that the advertisers need that aren't actually in the events. So the event has an indication of a line ID, which the line ID is basically one particular ad that's going to run somewhere. So an advertiser may have a campaign that they're running that with a whole bunch of different ads that are going to run targeted to different users and running in different places. Each individual ad has a line ID, but then we need to go into a lookup table to find, okay, so which advertiser is that? Which campaign are they running? Oh, by the way, what currency are they using? Because we want to convert, internally everything is in dollars, but maybe this publisher is in Canada, so the publisher wants to get paid in Canadian dollars, but the advertiser is using euros, whatever. So those all need to get converted. And then, anyway, so then once those declarations are done, then the results sent through a Tranquility bolt that sends it off to Druid. So that's all pretty simple, but then there are conversions. So what are conversions? So this is pretty much the same scenario again. So we have our user out there who is, he goes to a web page, and we show him an ad. So he sees an ad, say, this Walgreens red nose campaign that was going on. When he sees the ad, there's the little pixel that goes to us. That's then the 1B that says, hey, the user saw an ad. And again, if he clicks on it, there would be another indication. But then sometime later, could be hours, let's say that user goes off to that advertiser's website and does something interesting. Now, interesting is whatever the advertiser decides is interesting. It might be they actually bought something. They might watch a video, they might, register their, log in and create an account. But anyway, the advertiser, then we get a pixel from the advertiser saying, hey, this user did whatever interesting thing this was, and there's a beacon ID in there. And the idea is that, at least in theory, the fact that we showed this user the ad induced them to go to that advertiser and do something interesting. And we want to figure that out. Now, the other complication is that there might be a lot of different ads in that campaign on different publishers. So which one got the conversion? So again, that beacon ID maps to a whole bunch of those line IDs. So we need to go find if we showed any ad that was any one of those line IDs and pick the best one, which typically means the most recent one. I mean, if we showed an ad yesterday and another ad today, the one today gets the conversion, except a click is always taken over an impression. That's just the rules. Why do we do conversions? Well, for one thing, it's useful information to the advertiser, because if the advertiser had one ad that's running over here and another ad that's running over here, and it turns out, well, gee, that users that saw this ad, a lot of them end up going and doing, buying something on my site, but the users that saw that ad aren't doing that. Well, that's useful information. They maybe want to tweak that other ad or retarget it. They're throwing it to the wrong set of users. Who knows? It's also good for Yahoo, because that's evidence that hey, those advertisements were actually good for something. So, since the impressions and clicks happened sometime in the past, that means we need to join those beacons back to the impressions and clicks that happened earlier on. Partly because there's a lot of information in the impression and click that isn't in the beacon. That we need that to record the conversion. And also the advertiser in the beacon, he doesn't have any idea which ads were actually shown, so we need to go off and figure out which ones were shown to that user. There are lots of clicks and impressions, so just keeping them in memory to do a lookup wasn't really practical. So we quickly settled on HBase as the place to store the impressions and clicks, and we'll look them up from there. Oh, by the way, I forgot the quiz. In this picture, so who's the customer in this picture? The customer is the young lady down at the bottom, right? Not the guy up at the top. Remember, if you're viewing web pages, you're the product. You're not the customer. So here's the slightly extended topology. The events come into the spout, and we go through all the extract and decorate. That box at the top is really a number of boxes. The impressions go off to a storage bolt. We need to look up from our table, because not all impressions and clicks are in campaigns that are going to do conversion. So we want to see for each one is, would we even do a conversion on this particular line ID? If not, there's no point in storing it. So the ones that are interesting, we store in HBase. And when a conversion comes in, we go in and look up and find all the line IDs corresponding to that beacon ID, go find all of the impressions or clicks for that user for any one of those line IDs, and if any one of them matches, we get a conversion. Oh, and kind of an aside, because the order of events coming in doesn't necessarily correspond to the order that they happened. There can be processing delays off in data highway, there could be beacon servers that are off in some other part of the world. So we'll delay processing of the conversions by a few seconds, just to make sure that the impression and click that happened before the conversion, before the beacon, actually makes it into HBase so we can find it. So version 1. So we wanted to really optimize pulling things out of HBase. So our key, if you're probably familiar with HBase, but you basically have a key which is essentially a byte array that you can fill in any way you want, and then one or more columns that you can fill in based on that key. And we just have one column that's basically the serialized event. So we'll go to the key, pull out that column, and that's the impression or click that we had stored. So the key has a hashed user ID. We hash it partly, to preserve anonymity, because we don't want anyone to be able to map anything back to a particular user. And it also spreads the keys out over the key space so that the traffic is spread out among the region servers. The line ID, so we can find the line ID, and the type, what's an impression or click, and then the time that the event happened. And those are all cleverly encoded in such a way so that if we ask for everything for a particular user ID and line ID, we would get clicks first, and we'd get more recent events first. So the first one we got back would be the interesting one. And then when we get the beacon, we look up all the line IDs and do a scan for each of those line IDs, and to get all the information, to get the clicks or impressions for each line ID, and pick the best one we found. And when we were also clever about when we did subsequent queries, for example, if we found something before, we would tune the subsequent queries to not return anything that wasn't interesting anymore. So for example, if the first line ID we had a click, well, there could be one of the other line IDs that had a more recent click that was interesting, but we don't care about impressions. So when we scanned subsequent ones, we'd tune the scan key so that we wouldn't get impressions. Well, it didn't work as well as we thought. It all seemed very highly optimal. We really worked hard to not return more data than we needed to. But it turned out, well, first thing, that there are relatively small percent of beacons that actually generate conversions. Definitely less than 1%. So most of those queries aren't returning anything. It also turned out, one of those little gotchas that they didn't mention in the specs when we implemented it, that some of those beacon IDs have lots of line IDs. Most maybe a dozen or so, some with hundreds, some with over 500. So that would mean we'd be doing like 500 little queries that wouldn't return anything for each beacon. And that just took a long time, and we couldn't keep up. We'd end up having to just throw away beacons because we couldn't look them up fast enough. So we needed to fix it. So we refactored. We threw out the version from the key. HBase will let you save multiple versions for a particular row, and you can configure it to only save a certain number of versions. And it actually, for a particular user ID and line ID and click versus impression, we really only care about the most recent one. So we took out the version or the time in the key. And then when we get the beacon ID, we basically just find the minimum and maximum line ID and scan for that user ID and anything in that range of line IDs. It turned out usually the line IDs for a beacon ID are somewhat compact, but not always. So we can end up getting line IDs back that we didn't really want, but we just throw them away. So we'll do one scan, get back some number of events, throw away the ones that don't make any sense, and pick the one, assuming we got anything, pick the one that's the conversion. So, what can I say? It worked. Using the HBase for join worked pretty well, at least at this scale. Yeah, we sometimes get rows back, more rows than we really needed, but that far outweighed the cost of doing all those non-productive scans. After the refactor, the topology keeps up very nicely now. We have one outstanding issue that we think we know how to fix. And every once in a while, HBase gets a little slow. It turns out, HBase has to do compaction. You put things into it, and you tell it to take things out when they get too old. And when it gets around to taking things out, that takes a little time. And because our traffic is cyclical, we get a lot more traffic during the day than in the middle of the night. Since we set the retention to 1 day, that means in the middle of the day when we're getting lots of events in, that's also when the database is doing a lot of cleanouts. So the plan is to set the retention to 1.5 days so that the cleanout is done in the middle of the night when we're not getting a lot of other traffic. Just some numbers, just to give you some feel for how things are. We've got 4 HBase region servers. That's plenty for us. Very, very ballpark numbers. We get about 1 billion clicks and impressions a day that we're processing. About 20 million beacons, somewhere in that ballpark. And that generates about 100,000 conversions. So you can say the hit rate's fairly low, but it's still useful information. It typically under 10 seconds from the time that an event happens to the time it's actually there available in the reporting system. So it comes through pretty quick, and actually most are much less than that. Only 2 or 3 seconds, but there's some tail for things that get delayed a little bit. And it takes about 20 milliseconds to do each of the HBase lookups. I'll see if I can get this to run. If I click, no. How would I get the little movie on this to run? Can you? That's like a little quick time thing. Can you? Sorry? Yes. It works for me when I'm showing it. Oh, there we go. Okay, so one of my colleagues did this, just a little example, and this isn't actually conversions, but it's just kind of showing that the data comes through fast. The little bubbles across the top are the number of impressions per minute for this particular campaign, and you could see the real time down at the bottom there. As the minute goes through, the events in the current minute are going up. And when it rolls over into the next minute, we're getting there. You'll see it only takes 2 or 3 seconds before we start getting impressions from the next minute. 5, 4, 3, 2, 1. Okay, so we rolled over the minute, and then just a couple of seconds later, we start to get the events from the new minute. Now, you'll notice that from the previous minute, there's still a few trickling in, but we've gotten most of them. So that's what I have. You got some spare time to work with? Any questions?
You were saying line ID. What's line
Line ID, okay, I thought I said that, but okay, the line ID basically identifies a specific ad that's being run. You know, an advertiser may have a campaign, I mean, you know, ideally it could be, you know, one line ID could be an ad in a newspaper, and another one an ad in a magazine. I mean, you know, in the online advertising, you know, maybe there's, you know, they've got one ad that's targeted for sports, and so it's going to run on a sports page, and another ad that's more targeted to young ladies that's going to run on a, I don't know, some page that's targeted for young ladies. So anyway, that's, you know, it would, you know, different creative, it would be different, you know, different ad, it would run different places. Yeah.
How do you deal with the different displays, like mobile versus iPad versus?
How do we know that the different displays and things? Okay, so that would be in the impression. So when the beacon is fired, the beacon actually comes from the user's browser. When go back here, you know, the user goes to the publisher. The publisher returns back some JavaScript that's running in the user's browser. The JavaScript goes off to the ad server and gets the ad, and then fires the beacon to the beacon server. And so there's all kinds of information in that event that goes to the beacon server, like, you know, what type of event, you know, with the browser, you know, the browser type. You can decode that from the what's the term for the, you know, that tells you, you know, you're running Firefox versus Safari versus Explorer and a bunch of other stuff.
So all kinds of bidding is happening in the beacon server?
Excuse me?
All kinds of ad bidding is happening on
The beacon server is just there to record what's going on. The ad server, right? The bidding is happening in the ad server. So, you know, the ad server will get in the request saying, so we want to show an ad to this user, and it'll send messages out to all these different advertisers, or, you know, actually companies that are managing advertisers, saying, you know, here's what we want to show. You know, give me a bid, and those will all be collected together in the ad server and sent back to the user. Yeah.
Why cannot the beacon send the line ID itself instead of doing a scan of all the line IDs, right?
The beacon server, you mean?
The beacon on the user actually, when you serve an ad, can you associate a line ID with the?
So,
Well, when we get the impression or click, that has the line ID in it. The beacon, when we're doing the conversion, when we're doing the beacon that comes from the advertiser, right? It just has the beacon ID. It doesn't have all the list of line IDs in it. I suppose it could, but that would make the event much bigger. And then they would have to change their, you know, anytime they tweak their campaign a little bit, added another line, they'd have to update their web servers. So that, you know, that's all part of how the ad is booked.
so how do you end up with multiple line IDs?
Sorry?
How do you end up with multiple line IDs on the maker?
How-
How do you end up, you said you can have multiple line IDs, right? And just use a range query.
Well, okay, you asked how do you have multiple line IDs in the beacon. The beacon just has a beacon ID, not a line ID. And we do the lookup, where'd it go? Oh, I keep going backwards, or forwards instead of backwards. You know, there's an HBase table that has the mapping between beacon ID and all the line IDs. So yeah, in theory, yes, you could put the list of all the line IDs in the beacon ID, but this is more convenient for the advertiser.
How did you implement this delayed processing, which you mentioned that you had to you know, ordered, and what was that delay, and what kind of buffer you had to put in?
It's a fairly short delay. It's, in seconds. It's not, but it's basically, it's a little bolt that has a little internal queue in it. When the event comes in, it's put
so
in the
it's
queue with
still-
a time, and there's another thread that takes them out at the other end, and
Okay, so it's
waits until the
effectively a
time is.
bolt. On the storm side, you use the bolt and then a different
Right.
thread pull and some kind of queuing with
Right.
How do you deal with the many-to-many relationships?
Excuse,
How do you deal with many-to-many relationships between the beacons and lines? So many lines are there and beacons.
how do you deal with the many-to-many, how do you deal with the many-to-many relations on the beacons? It's basically a table with two rows in it, beacon ID and line ID. So when we want to find all the line IDs, we take all the rows with the given beacon ID. And,
After that, how do you resolve that?
well, we find all of the impressions or clicks that match any one of those line IDs, and then the one that we pick is, we'll always pick a click over an impression, and and within those two, it's the most recent one. Does that answer your question? But, right. There's another system that's being worked on, actually, that is ultimately going to replace that does much more sophisticated rules for conversions, but that's not ready yet.
So as advertisers, we are kind of really looking into attributions.
Mm-hmm.
So do you have anything coming up?
Well, this attributions.
Right. So
Yep.
is it going to get better, like whether it's
Yeah.
from mobile?
Right. Like I say, there's another system that in development right now that's, it's there, just not completely hooked in. That's trying to be much more sophisticated about that.
The amount should be pretty quick. You mentioned on HBase your lookups are about 20 milliseconds.
Yeah.
What are you doing for your data set size and your retention of data ongoing?
We keep them for an hour, a day.
Just a day?
Yeah.
Okay. Should be pretty fast.
That's enough for actually the batch system keeps them around for at least a month. I didn't keep for much longer.
So all your queries against the current day?
Well, the past 24 hours.
Past 24
We
hours.
don't, it's just when something gets put into, the HBase is configured to only keep things for one day. So we put it in with the time, and when it gets to be a day old, HBase throws it away.
Yeah, because this is, we have this as a Lambda architecture, so we have the batch side to back it up. And
Right.
so when the batch job runs, which is going to run every hour or so. I
Yeah, it
don't
runs an
remember.
hour, and it's 3 or 4 hours behind.
Yeah, so it's 3 or 4 hours behind to make sure it's gotten all the late data it possibly can. And when it runs, it stomps over what's in Druid and puts the final results there. This is here mostly, like you said, an advertiser comes in and at some point they make a change to what's running, and they want to see results from that very, very quickly. They don't care if there's 100% of the data and it's exactly perfect. They just want to see what's happening because they made a change. And they want to see the result of that change quickly. And so getting results that are fast and at least decently accurate. They don't have to be 100% perfect, but decently accurate.
Are you streaming from the HBase to your downstream batch, or you're splitting the transaction, hitting both at the same time?
It's split at Data Highway. So Data Highway is a best effort delivery system doing massive scale from all the different data centers. And so it gets piped into Hadoop and HDFS at the same time it's written into Storm. Storm potentially is lossy, but we're prioritizing new data over old data. For HDFS, it writes everything in there, and it does it in an efficient way so we don't get lots and lots and lots of small files.
Okay, so your HBase is just transient, it's just there for a short time and go
Yeah.
away, doesn't matter. Okay, gotcha. Perfect, thanks.
Do you go back in the batch processing and attribute against impressions and clicks longer than 1 day, or is your attribution always within one, for events that happen within 1 day?
In the storm topology, it's just 1 day. That's just what we have the retention set to. The batch processing goes back, I think it's a month. 45 days? Okay. I stand corrected.
Although I hear they've been trying to negotiate it down to a month.
Okay, but
So-
you know, the number of conversions you get for something that old is really tiny.
Right. Yeah, but you have reporting both, you know, like from down, you know, back to, your reporting goes back to 45 or 30
Right.
days.
You know, and as Bobby said, for the first 4 hours going back, that what you're seeing is what the storm topology did, and then once the batch system runs with the more accurate data, it just replaces everything that's there. The user doesn't, the advertiser or the user that's looking at it doesn't particularly notice, except maybe some of the numbers changed a little bit. But.
I don't know if you covered this, but from the time the impression or click happens to the time that it gets reported to the user during the, through the stream process, how long does that take?
It's as short as 2 or 3 seconds, usually within 10 seconds. Occasionally longer than that, but the vast majority is within 10 seconds.
Cool. Thank you.
During this batch, do you provide any analytics to,
I'm sorry?
during this batch, do you provide any analytics to increase the chances of getting,
Do we increase the chances of conversion in the batch processing?
So we don't have a feedback path at
Right.
this point as far as, so the question is are there any analytics to improve the chances of conversion? So there is no programmatic feedback loop to be able to go tell the ad servers, this ad is better than this other ad at this point. I'm sure there are things that people are working on. We have this for, say, for budgeting, and so making sure we show exactly the right number of ads. Somebody said, I want to pay $1 million to show these ads. We want to hit it on the nose, $1 million. If we show more ads than that, we can't charge you for it. If we show less ads than that, well, we can't charge you for that either. That's bad. And so we do have that programmatic feedback loop through Storm, and it's given us quite a large lift that way. And I'm sure there are people in the advertising side that are looking at how to put more of this in programmatically. But at this point, it's going through the advertiser. A lot of them want to have control over tuning the parameters to make sure everything works well.
Okay. Is there a sessionization process involved? To choose the best event that gets the conversion? So do you sessionize the set of events coming from a single user?
I'm sorry, I'm not.
So since you're processing a lot of events, right? So do you sessionize them?
Sessionize them?
Yeah.
So
No, it's based on just the user ID.
Yeah.
Or
we don't do sessions at this point.
Yeah.
To be able to say that this user saw this web page and they moved along in this way, it doesn't. It might make sense in doing attribution, but at this point, it really doesn't make that much sense with the simple rules we have.
Oh, and on the report that you're displaying to the users, how does it get from HBase to that? Not, I mean, in terms of aggregating the data, are you just summing up from HBase? Are you using other tools like Phoenix?
It's not HBase, it's Druid.
So
Oh.
So HBase is used as a temporary intermediate table. So we're doing a streaming join. It's just as a join that looks back over a day's worth of data and 1 billion entries. And so being able to do that is kind of big. Typically in Storm, when you do a streaming join, you're going to cache most of that data in memory. I'm looking back over a second, 2 seconds. This is how Spark Streaming does it. So for Spark Streaming, you want to do a look back join on your window over the last hour. It will have all of that hour stored in memory, in fact, replicated twice for fault tolerance purposes. And so because of that, it works really well and it's very fast, but if you get something that's very big where I have to look back a long period of time, that becomes painful. And so that's really the core of this, is saying this is how we've been able to do a large streaming look-back join. But the aggregates themselves, what we're serving up, is going through Druid. And so once we make that join, all the aggregates, everything else gets written out to this other system.
Thanks.
How do you guys remove duplicate beacon calls? Like if someone just keep refreshing the page, you will have multiple beacon calls, right?
If they refresh the page,
Yeah.
I think that's handled in the beacon servers. Actually, I'm not sure exactly how that works, but
Yeah, I don't completely know. I know we don't do a whole lot with data deduplication on the Storm side, because again, this is approximate data. If I double count something, it's probably not the end of the world. I think that there's a fair amount of deduplication work that happens on the batch side, but I'm not as familiar with that, so I really don't know.
yeah, there is some traffic protection that's in there. Didn't even mention that. Checking for fraudulent clicks to a certain. In the Storm topology, it's fairly simple. In the batch processing, it's much more sophisticated. And the batch system would capture that kind of thing.
Why could the join retain the wrong line ID?
Could the join have the wrong ID?
Line ID you mentioned in the new word.
It's not that it would have a wrong line ID. It's just that when we query from HBase, we might get some line IDs that didn't actually match that batch ID, just because they were in the range. Maybe this beacon ID had line ID 10 and 15, but there was also a line ID 12 that wasn't associated with that beacon ID.
So part of this is when you're dealing with state, the access pattern becomes kind of critical in getting decent performance. And so what they were doing before was they were trying to target very specifically what were the line IDs, what were these small pieces, and doing the join very accurately without extra data. But that made it very random. Well, it wasn't the randomness, because most of the data was probably in memory, but it was the sheer number of operations that you had to do the back and forth to HBase. And so you do one query, get results back, do another query, get results back. That was very slow. Whereas this, you're doing one query, which may get extra data, but the amount of extra data is less overhead than the number of back and forth operations that were happening. And so we just grab extra data, throw some of it away, because it's faster than trying to get only the data we care about.
Yeah, are we about to get kicked out here?
So just quick, one last thing. You said the HBase is just used for the streaming one-day join. What do you use for the 45 or 30-day join?
HDFS. That's in the batch system.
Like you just, what do you, like
We grab all 45 days worth of data as part of the input format, aggregate it all up, do the, through the shuffle phase, and.
Is it like in Java or Pig type of?
Probably Pig.
I think it's in Pig.
Yeah.
Okay. Interesting. Okay.
And that you can tell there's a timestamp that's associated with the event, so you can.
Right.
Well, no, not for conversions. Never mind. I'm thinking of a different join. Yeah, I think. Thanks. Yeah, they're gonna kick us out. If anyone has any questions, we can meet out there.